Question 10 was a real test, so it was quite difficult to come away with much from parts C and D especially. Part A and B were a little bit more doable, but still it's a fairly tough question overall. So let's have a look at this in more detail now. So part A says that we explain why the graph of f has a local minimum when x equals 5, which is here. So a local minimum is at a point like this. And the way to identify or show that you have a local minimum is when the gradient of the function changes. So here we can see we've got the gradient is negative. At this point here it's 0, and then here it is positive. So this is the characteristics of a local minimum, that the gradient changes from negative to positive. Now if you have a look in the graph, this isn't a graph of y equals f of x, it's a graph of y equals f dash x. So this is a graph of the gradient. So we can see that the gradient goes from negative here through 0 to positive. So therefore this point here at 5 must be a local minimum. For part B it says find the set of values for which the graph of f is concave down. So concave down is where the second derivative is less than 0. That's how we identify concave down. Bearing in mind we've got a graph of the first derivative, the second derivative will be the gradient of f dash x. So we are looking then for where on the graph the gradient is negative, and we should recognize that the gradient is negative between this point here at x equals 2 and this point here at x equals 4, which we're told is a local minimum on this graph. So therefore the set of values for x for which the graph is concave down is going to be between 2 and 4 exclusive, so not including 2 or 4, because at those points the gradient is 0. So between 2 and 4 the graph is going to be concave down. In part C and D then the challenge really starts. So in part C we are told that f of 0 equals 14, and given that we're asked to find f of 6. So in this question we hopefully can recognize that we are going to be looking at something to do with these areas and integration. So we can start off by thinking that the area under this curve between 6 and 0 will be the integral of f dash x, because the curve we've got here is f dash x. So we want to integrate that with respect to x, and that would give us the area, and that would give us between 6 and 0 we are going to be looking at the function f of x. So we would express this as f of 6 minus f of 0, and that would give us the area underneath the graph. Now it would give us the area under the positive sections. So remember, these are actually negative. So when we're looking at the areas, we are told that the area here is equal to, in section A is 12. The area in section B is 6.75, and the area in C is 6.75. However, because these are negative here, or underneath the x-axis, if we integrate these values here are actually negative. So because we're not taking the modulus, if we're just looking at here, the difference between f6 and f of 0, that would be negative 12 minus 6.75 plus 6.75. So these two are going to cancel out, and you're going to end up with this equals negative 12. We're told in the question that f of 0 equals 14. So we can now rewrite this as f of 6 minus 14 equals negative 12, and therefore we can rearrange that and write f of 6 equals negative 12 plus 14, which equals 2. The real quiz comes, however, in part D. So we're told that g of x is the same as f of x all squared. So the question says, given that the derivative of 6 equals 16, find the equation of the tangent to the graph of g at the point where x equals 6. So, to work this out, we are looking at the tangent. We're trying to find the tangent. Therefore, the starting place is looking for the gradient. So to find the gradient, we were going to take our function here and find the derivative. So what we're trying to find then is g dash x. Using the chain rule then, this is going to be, the derivative of this is going to be 2 times f of x multiplied by what's inside the brackets, which is going to be f dash x. We more exactly want to find the gradient of 6, so we're trying to find g dash of 6, which is therefore going to be twice f of 6 multiplied by the derivative of 6. We found that in part C, f of 6 was 2, so this is going to be 2 times 2, and in the question we are told that the derivative of 6 is 16, so this is going to be 2 times 16. So we can say that the gradient at that point where to the tangent at x equals 6, we can say that the gradient is equal to 64. So we've got the gradient, we've got the x-coordinate, so we can find the y-coordinate, or g of 6, by substituting in 6 into our function up here, in effect finding f of 6 all squared. F of 6 we found was 2, so 2 squared is going to give us 4. So, in order to find the equation, we then need to use y minus y1 equals mx minus x1. So in this instance, we've got y minus our output, which is 4, which came from here, equals our gradient, which we said was 64, multiplied by x minus our input, which is 6. And if you expand that, you get y equals 64x minus 380.